In this video, I am discussing MOT postulates and difference between atomic orbitals and molecular orbitals and different diatomic molecules, how they are filling electrons with respect to MOT and what's the conditions for to form MOT and all these things I am discussing in one video. Here, any molecule they formed by combination of atoms. Okay, that may be same atoms or different atoms. They can combine, they can form molecule. We have too many basic theories, but VBT and MOT is the quantum mechanical theory, which is explaining chemical bond formation. We know that when chemical bond means a chemical bond may be defined as the force that holds the atoms together within a molecule. That's we call chemical bond. Whenever bond formation occurs, compared to atoms, molecules are more stable because they have less energy. Less energy means more stable. Energy inversely proportional to stability of the molecule. We'll discuss why like that also. We may can discuss with respect to thermodynamically. Not now here. We'll discuss later. And here, what is the difference between atomic orbitals and molecular orbitals? Itself the given meaning. Atomic orbital means this related to atom, this related to molecule. Got it? There is a basic difference. You have to know that one. You can see here. Atomic orbitals, first one, this belongs to one atom nucleus and surround the electron cloud. Wherever electron cloud is maximum probability is there around the one nucleus. That's we call atomic orbital. But in the case of molecular orbital or S2 molecule formation or O2 molecule formation, electron cloud we are finding between two nucleus. Between two nucleus. That's we call molecular orbital. You can find out here different differences they given. Formed by electron cloud around the atom, formed by the fusion of atomic orbitals that have nearly the same energy. So they are there to forming. The shape is determined by the type of atomic orbitals SPDF. A finding a probability of electron that is spherical shape that's we call S orbital. This all these things atomic structure we discussed that one. Shape of the orbital. The shape of is determined by the shape of the atomic orbitals that make molecule like tetrahedral like that we are discussing now, those things. And atomic orbitals and their structure, their energies, everything decided by Schrodinger equation. But here molecular orbitals we are explaining by using linear combination of atomic orbitals theory. They have some conditions which one they can overlap. And atomic orbital is the related to one nucleus they can attract around the nucleus. That's we called monocentric. But here molecule means they have too many atoms they're combining. For example, CH4, 5 atoms they combine. That electron cloud under the control of these 5 atoms are they attracted by 5 atoms. That's we called polycentric. Monocentric means one nucleus. Polycentric means more than one. And single molecules affect the electron clouds. Anyway, we know that one because one atom it electrons. But in the case of here, more the nucleus may can affect the electron cloud because SF4 you can take any molecules. That electrons which are distributed between two atoms that controlled by all those atoms. So this is the difference between atomic orbitals and molecular orbitals. Here one more point, make and second to NCRT only are discussing. Atomic orbitals when they are combining, they form two set of orbitals. One is bonding molecular orbital, other one is anti-bonding orbitals. Anti-bonding molecular orbital have more energy than bonding molecular orbitals. So how many atomic orbital participating to form molecular orbitals? That many only molecular orbitals will get. For example, two orbital participating, then two molecular orbitals will get it. Formation of molecular orbitals, linear combination. For example, I am discussing here. Suppose two atomic orbital participating to form molecular orbitals will get two molecular orbitals. If 6 orbitals participating, you'll get here 6 molecular orbitals. I am trying to explain here by using H2 molecule formation. H2 molecule formation. You can assume that one HA atom and this is another HB atom. According to Schrodinger equation, atomic orbital represented like wave. This is the wave I'm taking psi A. This is another wave psi B. Here two chances is there when they are waves we are mixing. Two chances we have that one. Maybe constructive wave, destructive wave. Two possibilities is there, which can form constructive interference that's we call bonding molecular orbital, which can form destructive interference that's we call anti-bonding orbitals. So here AB formation, nothing but psi A plus or minus. Two chances you have that one. So I'm explaining both. Suppose psi sigma bonding, they're forming molecular orbital. Bonding molecular orbital they're forming. Suppose we'll discuss that is sigma AB molecule forming. In that case, psi A plus psi B. This is our constructive wave. So this is the one first wave A orbital or wave function, and second also they are moving same phase. Then that's we call constructive interference. This is we call constructive interference. Interference. If suppose they are forming antibond, this we call even bonding molecular orbitals also. Bonding molecular orbital. Okay. Other one they are forming psi AB anti-bonding, that's we call star. Anti-bonding is star. Then sigma A minus psi A minus psi B. This is another chance. We are discussing this is destructive wave. They are forming destructive wave. So destructive wave means opposite to each other. They're canceling each other. So assume that one A psi A this is, and they are moving opposite other one. This is we call destructive wave. This is psi B. So this is we called psi A minus psi B. Okay. This is forming anti-bonding. AB of anti-bonding. Anti-bonding indicates star, that is asymmetric in nature. Asymmetric in nature. Please keep in mind that word. Anti-bonding is asymmetric in nature. Bonding is symmetric in nature. Then conditions for the combination of atomic orbitals. We'll see which can form molecular orbitals. The combining atomic orbitals must have the same or nearly the same energy. Like 1s, it can easily can combine, they can form molecular orbitals. Energy difference should be very less or almost nearly same energy. They only can form all these things. And next one, you can take it 2s, it can overlap easily. Only these can form easily molecular orbitals. And symmetry as next. The combining atomic orbitals must have the same symmetry about the molecular axis. So we can assume that one mostly we are taking here means px they can participate in the combining, they can form molecular orbitals, and pz like that. So you have to take same symmetry. You should not take here px and py overlapping. This is not acceptable. The combining atomic orbital must have overlap to the maximum extent. So greater the overlapping, stronger the bond. That's the basic point. So here we are discussing anyway. We know that one description of atomic orbitals, four quantum numbers. We have that one n, l, m, s. So n, l, and s is similar. That is which we are following all the rules also same. This doesn't matter. Only m is going to be taking. So m we are representing here another quantum number, another symbol, that is lambda. They are showing here. So on lambda values and everything also same, minus L2 including 0 plus L. So here we have two types of Sorry, three types of molecular orbitals. We have that one sigma, pi, and delta. So with respect to here, which is they are showing lambda equal to 0, that's we are taking molecular axis. That's nothing but most of the cases z axis I am taking molecular axis. Which one have m equal to 0 or lambda equal to 0, that can form sigma bond. That's we call sigma orbitals, then it can form sigma bond. And other one we have that one lambda equal to plus or minus 1, these can form pi bond. This can form pi bond. Like m value only, the orbital which is belongs to plus or minus 1, those can form pi bonds. And lambda which one have plus or minus 2, it can form delta bonds. That's we don't have in the syllabus up to JE level. So we'll see that's later. JE and NEET level we don't have in these things. Means 11th standard you can see NCERT book how much is there. We can discuss these are later. Means not మామూలు బిస్కెట్లు కదరా నాయన.